Let's do another stoichiometry problem. In stoichiometry, we're looking at how mole ratios are in chemical reactions from the coefficients of the balanced chemical equations, and we're looking at the masses of reactants and the masses of product. And so let's take this reaction. Let's show how hydrogen peroxide decomposes to make water and molecular oxygen. And the balanced chemical equation says 2H2O2, 2 hydrogen peroxide, decomposes or reacts to make 2H2O plus O2. So 2 moles of H2O2 decomposes to make 2 moles of H2O plus 1 mole of O2. Where 2 parts of hydrogen peroxide decomposes to make 2 moles of water plus 1 mole of O2. And so our ratio is 2 to makes 2 to 1. And so what is the theoretical yield of water if 50 grams of hydrogen peroxide completely decomposes? What is the theoretical yield? How many grams of water are produced if 50 grams of hydrogen peroxide completely decomposes? So our roadmap for these problems has been grams to moles to moles to grams. So we're going to go from grams H2O2 to moles H2O2 to moles H2O to grams H2O. To go from grams to moles, we're going to use the molar mass of hydrogen peroxide. To go from moles hydrogen peroxide to moles of water, we're going to use our stoichiometric ratio. That's the coefficients to our balanced chemical equation. And then go to moles of water to grams of water, we're going to use the molar mass of water. So 50 grams of H2O2, we're going to convert that to moles H2O2. And the molar mass of hydrogen peroxide is 34.0 grams per mole. Grams H2O2 divided by grams H2O2 cancels. I've got moles of H2O2. Now we want to convert moles of hydrogen peroxide to moles of water. But we need our stoichiometric ratio. So it's 2 moles of water is produced from 2 moles of hydrogen peroxide. And that may seem like a redundancy. 2 divided by 2 is 1. But our units are important, and developing a process that we can use over and over again is important. It's like developing your technique for shooting free throws. You want to have this, you want to develop the right technique. You want to practice over and over again so you get that muscle memory in shooting free throws. You want to get this chemical memory developed in your mind by doing the same process over and over, but you have to be doing it right. So even though it seems like a step that's not needed, it really is. Moles H2O divided by moles H2O cancels. We've got moles of water. And a mole of water is the same as 18.0 grams of water. So now moles of water divided by moles of water cancels. And now give us grams of water. 50 divided by 34 times 2 divided by 2 times 18. And that would give me 26.5 grams of water. That's my theoretical yield of water that can be produced from 50 grams of hydrogen peroxide. How much oxygen was produced? Could be a second part of this equation, this problem. a straightforward, very quick way of doing this is remember our law of conservation of matter, in that the total grams of our reactants that are consumed has to equal total grams of product. So if I started out with 50 grams of reactant, which is H2O2, and I've made 26.5 grams of water, I can just, by simple subtraction, figure out the grams of hydrogen that I've produced. So 50 minus 26.5 is 23.5 grams of molecular oxygen, O2. But let's check that. Let's go through our stoichiometric process once again to get that practice down and see if we can't come up with that same answer. So we're going to take grams of hydrogen peroxide, change that to moles hydrogen peroxide, change that to moles molecular oxygen, and then we can change it to grams of molecular oxygen. So 50 grams of H2O2, 1 mole of H2O2 is the same as 34.0 grams of H2O2. So now we got grams H2O2 cancels out. I've got moles H2O2. So I want moles H2O2 in the denominator so that would cancel out. I want moles of oxygen this time around. And so this is going to be my stoichiometric ratio. So go back to my balanced chemical equation up top. It says that 2 moles of H2O2 reacts to produce 2 moles of H2O and 1 mole of oxygen. So it's 1 mole O2 to 2 moles of H2O2. And now, to get the theoretical yield of oxygen, how much of that was produced, I want grams O2 divided by moles O2, and it's 32.0 grams per mole for molecular oxygen. So moles O2 divided by moles O2, that will give me grams O2. So 50 divided by 34 times 1 divided by 2 times 32. Aha! Gives me 23.5 grams of oxygen. That's what we predicted we would get by using the law of conservation of matter up above, or using our stoichiometric method. We came up this way. Now, side note, occasionally you might come up, if you do it the two different ways, we might have come up with 23.4 or 23.6. And that's just rounding error. If we're limited by the number of sig figs, we may be off by maybe plus or minus 1 that last digit. And so don't let that cause you consternation if that were to happen. So this is another example of stoichiometry.